Alright, hi everyone. So in this video, we will talk about section 3.8, which is the implicit differentiation. What did implicit differentiation mean? So let's take a look at the equation below here. I have y equal 2x plus 1. This is explicit equation. Why is called explicit? Because y is isolated by itself. So any equation like y equal 2x, y equals sine x plus 2, or y equals square root of x cubed minus 2, you notice that all of these equations that I have here, it's the y is being isolated. So the y stand by itself, we call the equation is explicit. And if we want to find y prime, all we have to do is we just take the derivative on the right side, because all of this will become y prime. However, there will be some other equation. It's called implicit. What is the implicit equation? It means the equation that the y haven't been isolated. So for example, 2x plus 3y equal 2. The y is actually stand within x and not isolated by itself. So in this equation, y is still the function of x, but if we isolate for y, and the result will be explicit. So if we have an isolated y, the result is implicit, but if we isolate it, we're gonna have the explicit. Okay, so let's take a look at this problem and then isolate this for y. So I have 2x plus 3y equal 2. Then isn't that my 3y is 2 minus 2x? And my y gonna be divide everything by 3. I will have negative 2 over 3x plus 2 over 3. Okay, so when I have an implicit equation, I isolate for y. I have an explicit equation. Now, can I find y prime? Yes, I can find y prime. My y prime is, what is the derivative of negative 2 over 3x, which is negative 2 over 3. And the derivative of 2 over 3 is 0. So my y prime is negative 2 over 3. Perfect. Okay. But the problem is not every equation we can isolate for y easily. For example, if I have this equation, 3x cubed plus 9y cubed equal to xy. Can I isolate for y? It's going to be very hard because y cannot be combined. Okay, you have one is yq and then you have the other y. So when this is the case, we won't be able to isolate for y. Then how do we gonna find the derivative? Okay, at this point, we need to use a technique called implicit differential equation or implicit differentiation. Okay, so how do we, let's take a look at back this problem. Let's try to take the derivative implicitly. So how do I take the derivative implicitly? So first of all, I will look through the equation. Okay, and to find the derivative implicitly, I will have to take the derivative on both sides. So let's take a derivative on both sides. Now let's consider derivative of each individual term. So what is the derivative of 2x? The derivative of 2x is 2. And how about derivative of 3y? So when we have derivative of 3y, this no longer the variable x, right? So whenever the variable and the x is not the same, if you can remember, we have the chain rule. If you have derivative of 3u, you're gonna have to have 3 times u prime. Okay, so the same thing, this is gonna be 3 times y prime. Okay, so you will have plus 3 times y prime. Why 3 times y prime? Because derivative of 3y is 3. And you multiply the chain rule of y, which is y prime. Think about it, if we forgot to do y prime, and let's see the problem makes sense. So if we forgot to do y prime and we just take the derivative of 2x is 2 and 3y is 3, what is the derivative of 2? Is 0. That doesn't make sense because 2 plus 3 equals 0. No way, right? So That also explains why we're gonna have y prime. It must have the y prime there, otherwise the problem doesn't make sense. And the right hand side derivative of 2 is 0. And from that, can we isolate for y prime? Yes, we can isolate y prime by subtract 2 on both sides. We have negative 2. And then divide 3. We have y prime equal negative 3. Okay, now compare our solution for both of them. So this one, we solve the y and we take derivative. We have y prime is equal negative 2 over 3. On the right hand side, we take the derivative implicitly and we turn out to get our derivative is negative 2 over 3. So this telling you what when you take the derivative implicitly, as long as you apply the correct techniques, you will get the same result for explicit. Okay, so this is one of the techniques for find the derivative if you have the equation that difficult to isolate for y. All right, so let's try that with the first example using this step procedure. So first, we're gonna take the derivative on both sides. So let me take the derivative on both sides, d over dx of x squared. If you want to break the term individually like this, that is more than welcome. And then d equal d over dx of 2x. Now, what is the derivative of x squared? We're taking the derivative on both sides. I break it down individual term because I know that we're going to take the derivative of x squared, derivative of y squared, and 2x. So we will have 2x plus y involved. So we take the derivative normally, which is 2y, but make sure we also have to include y prime. If you don't want to use y prime, yes, that's fine. You can do dy over dx. It will be the same thing. Okay, so y prime, which is 2 equal 2. The derivative of 2x is 2. Now what? Now on the step 2, it say gather all the y prime in one side. So this is the term that have the y prime. So I'm gonna put that in one side, and we will have 2y times y prime equal 2 minus subtract 2x on both sides. 2 minus 2x. Then our y prime will be 2 minus 2x over 2y. Okay, this is gonna be our derivative implicitly.